Hello, everybody. So I am joined today by the team behind one of our Lilly funded research projects, which is looking at red light therapy in children. My name is Maria, and I am the research manager for the Lilly Foundation. But enough about me. Let's turn over to the two far more interesting people in the room. Would you like to introduce yourselves and your roles?
Hello, my name is Glen Jeffery. I'm Professor of Neuroscience at University College London at the Institute of Ophthalmology, and my research is very much focused around mitochondrial function, what happens to it as we get old, and what happens to it when it doesn't work very well from kickoff. And I am basically a person that works on how we can manipulate mitochondria to improve them using light.
And my name is Annegret Dahlmann-Noor. I'm a children's eye doctor. I work at Moorfields Eye Hospital in London and also at UCL, the same Institute of Ophthalmology as Professor Glen Jeffery. My passion is translating research to treatments for children who have got different health and eye conditions. So I work with Glen on this project because he has done so much work on red light and the beneficial effects it has on mitochondria. And at my end, I see children in my clinics who have got mitochondrial conditions. So I'm naturally curious to see whether red light treatment might help the children in my clinic.
Amazing. Thank you both so much, and thank you for being here today. So I guess my first question is, can you briefly explain what the red light study is and why is it important? So Glen, I'm going to come to you first.
Yeah, sure. We've been working on red light for a long time, mainly in animal models in aging. The interesting thing about mitochondria is they're rather sensitive to light, and you can change their function with light. So for instance, we can age mitochondria and run them down a little bit if we use blue light. But at the same time, mitochondria also absorb certain wavelengths in deep red light. Now, this kind of the mitochondria are batteries in our cells. And what this does is it recharges the battery. So if we've got old mitochondria, we can expose them to red light, we recharge the battery, and we can do things like improve people's vision. We can improve animals' mobility. Now, the same is true if mitochondria aren't working terribly well because of a genetic problem, as we find with some mitochondrial children. The red light is absorbed, and if you want to think about it, you can think about it as warming them up. It's been done for a number of years in a range of animal models, and there's every reason, theoretically, why it should work in the case of mitochondrial conditions in kids.
Amazing. And Annegret, do you have anything to add to that?
Yeah, just the practicalities for kids. So my hat is always on for the kids, right? So everybody who takes part in our study gets one of these red light torches. And what we ask them to do is to hold it in front of their eye for 3 minutes every morning. 3 minutes on the right eye, 3 minutes on the left eye. Some kids do it before they even get out of bed. And if they think that the light is too bright, they can close their eyelids, because really the light will go everywhere. It will go to the lid muscles and to the muscles on the outside of the eyeballs as well. And then we ask them to come to my clinic at the hospital, my research clinic, every 3 to 6 months to see how they're getting on. So we have a little chat and we measure where the eyelid position is and how well they can move the eyelids up and down and how well they can move their eyes side to side as well. Because what happens when you have a mitochondrial condition, then sometimes children can't lift their eyelids up properly, so they are droopy. The technical word for that is ptosis. So in order to see better, they have to sort of tilt their head back. And we hope that with the red light treatment, the muscles start working better so they can open their eyes more and look straight ahead.
Incredible. And incredible that something so simple can be used. It really is very interesting. And obviously you've sort of already touched on, I suppose, some of the methods that you're using in this study. But Glen, can you maybe add something else to describe the methods that are being used in the study?
Annegret's covered it very well. It's very, very simple. And we've used these methods on older people who have got mitochondrial problems through aging. We found that the children involved in the study so far have really adapted to this absolutely perfectly well. They built it into their environment. They wake up in the morning, they have a go at their red light torch, and then they go off and clean their teeth and get on with their day. It has proved to be extremely simple and straightforward. It's not high technology. It makes biological sense when you know a lot about mitochondria and light. And just simply three minutes. Don't have to keep your eyes open if you don't want. And the simplicity and the science behind it are just, well, I start off by the notion is, can I explain this to my mother and will she get it? And I have, and much to my surprise, she did get it.
Always good. And I think that's really important as well, that it can be built into that everyday routine, and hopefully that will obviously help with using this in future. So, Annegret, what stage are you currently at with this study?
So we have got so far 5 children who have signed up to the study, and we have got 10 places on this program. So we would like another 5 to sign up, really. Of the 5 who are already part of the study, 3 have got their red light torch at the first visit, and the other 2 at the second visit, 3 months later. Because when you do a research study, you always want to make sure that whatever you observe isn't just by random chance. So you need a control group. So in this study, the children who don't get the torch at the first visit, but by the time of the second visit, are our control group. But everybody gets a torch. The only question is whether they get it right on day 1 or 3 months later. And that pattern will continue. So we are hoping that another 5 will sign up, and then they will get their red light torches. And then we will check their eyes at the beginning, and then again 3 and 6 months later. And if they stay with the study, then we will see them all together up to 5 times at the hospital to see the improvement that we are hoping for, and to see whether it's sustained, so whether it becomes better and whether it stays better over a long period of time.
So you've said that you're looking to recruit hopefully another 5 participants. Glen, if you could, what criteria is being used to actually select participants for this study?
Well, the key criteria are children with a genetic confirmation of mitochondrial disease. So we know the platform here. We are using as our primary target ptosis, that ability to open your eyes properly. And many children with mitochondrial conditions have got problems with that. So that's our primary target. I must say that as we spend more time with children with this condition, we're picking up on other things that they perhaps don't do as well as normal, ordinary children. And we're keeping an eye on those as well. So we're quite interested in whether they have double vision, what their mobility's like. You know, how'd you kick your legs out of bed in the morning? Do you do that kind of happily and quickly, or is it all a bit of a struggle? So we like to get a holistic picture of the children, but our primary one is, do you have a genetic confirmation of mitochondrial disease? And do you have a problem lifting your eyelids?
And I guess